Hello, good evening. Welcome to Cold Night ANZ. So now we're across Australia and New Zealand. And tonight we have a special guest, Jason Taylor. Jason, how are you?
Good, thanks, Marcel. How are you?
Doing well. Feeling pretty much pretty, very well, just knowing that you're here tonight. It's a pleasure to have you in our user group. And yeah, it's an interesting topic we're bringing like tonight, like effortless distributed systems with Aspire. Can you bring it to us like some insights? What is that
Yeah,
about?
for sure. No problem at all. So, really, effortless distributed systems is about removing the friction that we face when we try to build a distributed system. Obviously, there's a lot of challenges that go into building a system that has to communicate over the network. It has to be fault tolerant, has to be durable. And so, choosing the right tools can make a big difference. So, I'm going to show you how three tools tonight. I'm going to show you Aspire, I'm going to show you NService Bus, and I'll show you the Azure Developer CLI, so we can start to remove that friction all the way from local dev into the cloud.
Well, that's a great session. I like integration. I like all systems connected. So it's exciting, right? So before we start, Jason, let me just introduce like the user group to well to the audience in here. So if you're coming here for the first time, so you know like that we have a purpose, right? We are a group of developers. We love coding. We follow best practices on software development languages and technologies. In general, like we tend to focus our sessions more onto the Microsoft stack, but we're open to all technologies. And if you're like a developer, you know that we're here to share like content that is going to enable you to success in your career, right? Also, I'd like to mention that we are part of AzureTire.com, which is a community of cloud native enthusiasts, and we get to share the latest and greatest in the cloud native space. Also sponsored by the .NET Foundation.org, which is an entity that looks after the different .NET open source projects, and JetBrains, software tooling for developers. With no further ado, Jason, let me just bring your screen, and we
Thank you.
can, and the floor yours.
All right. Hi, everyone. I'm Jason Taylor. I'm a Microsoft MVP and a solution architect at Particular Software, which is the team behind NService Bus. Now, as I mentioned, building distributed systems can often feel complex, slow, and fragile. So tonight, I'll show you how the right tools can remove that friction so developing distributed systems feels effortless all the way from development to the cloud. So tonight's session is going to be interactive. So jump onto slido.com and enter the code effortless, or you can grab a link from the chat if you like. Marcel, if you could just pop that in there, just slido.com.
Yep, let me just grab that.
Awesome. So we'll use it for a few polls, and you'll help shape the path we take through the demos. There are 8 different variations of this talk, so be sure to get your votes in. So while you're joining, let's start by defining what we mean by a distributed system. So a distributed system is a system of multiple services or components that are working together. Now those services are running on different machines. So think servers, containers, cloud resources, virtual machines, and they communicate over a network, so the whole thing behaves like one application. Here's a simple but common distributed system. We've got a web front end, a web API backend, and a database. Now, whether your system looks small like this or grows into something much larger and more complex, the same challenges show up. We have orchestration, service discovery, reliability, configuration, observability, and deployment. And these challenges are exactly what we aim to simplify with effortless distributed systems. So effortless means shifting the focus back to what matters, and that's delivering features that users care about. We want to reduce wasted effort by eliminating manual setup, wiring, and boilerplate, and we want to simplify the hard parts so that teams can move faster and with greater confidence. Now, of course, effortless doesn't mean no effort. It means reducing friction and spending effort in the right places. Now, of course, to do that, we need a solid foundation, and that's exactly where Aspire comes in. So Aspire simplifies distributed systems development from the start. If you haven't heard of Aspire before, it's a framework that gives us tools, templates, and packages for building distributed apps. It was previously known as .NET Aspire. Teams changed it to be just Aspire because it's much bigger than just .NET. At its core, there is a code-first app model, which acts as the single source of truth for services, resources, and how they connect together. It also provides pre-built integrations, and this supports common infrastructure such as messaging, databases, caching, and hosting. And importantly, Aspire is designed to work end-to-end, from running locally during development all the way through to deployment in the cloud. All right, let's see Aspire in action. We'll dive into our first demo and we'll add Aspire to an existing app so you can see just how quickly you can get started and simplify building distributed systems. So I have a really simple application here. You might have seen something like it before, but it's a web UI front end that's running on ASP.NET Core Blazor server. We have a web API backend, which is running on ASP.NET Core Minimal API. And we have a shared project, which defines contracts and common types that are used between the front end and the back end. Now, if I want to start this project, I can do so by first running the front end. So I'll run that and start without debugging. And I get my console window starting up. I can monitor that if there are issues. And over here, I can start the web API, the back end. And it's the same thing. I've got another console window so that I can monitor that if there are issues. So we've got two console windows, and now our solution is running. So this is, as I mentioned, an ASP.NET Core Blazor server app. And it is primarily the new, .NET new project template. But I have made a couple of tweaks. So we still have hello world. We have a counter because developers love counting things. And we have a weather forecast. Now, one of the tweaks that I made was to make it a little bit less reliable, because that's the thing. The first fallacy of distributed systems is the network is reliable. I wanted to illustrate that in this application. So any request to this solution is going to fail about 30% of the time. We'll see if we can fix that as we move through it tonight. But I don't want you to worry too much. I've also added a bug report. So if we do run into issues, we can submit a bug report. No one's going to read them, but at least we'll feel good being able to do that. And of course, that's going to fail 30% of the time as well. Now, if this was a real application with customers, of course, they might retry. But of course, we've taught them never to click the submit button twice, so maybe they'll just go somewhere else. All right, so you've seen the demo application, a couple of problems. Let's see how we can introduce Aspire and start to solve those problems. Now, if I want to add Aspire, I can do that through the command line or through Rider or VS Code or Visual Studio. Tonight I'm using Visual Studio, so I'm going to use the IDE. So I'll right-click on the Web UI project, and I'm going to click Add, and add Aspire Orchestrator support. And you can see here that it says, okay, we're going to do that, and we'll do that by adding two new projects, the app host and the service defaults. We'll look at those shortly. I'm going to do the same thing for Web API now. So right-click, add Aspire Orchestrator support. And what it's done is it started to create a code-first app model of our solution. You can see that it's listed both the Web UI and the Web API. I'll put them in this order. What we can define within App Host is our services and our resources and how they connect together. This is where we orchestrate our solution. So we also have service defaults. And service defaults is just a simple class library that holds common configuration shared across all our services. For example, there's open telemetry, there's default health checks, there's service discovery, there's resiliency, and all of this is code that we can now use and extend and modify. And we'll do that later on in our demos. If I go into WebUI program.cs, where this application starts up, you can see it's referencing service defaults. And if I go into Web API, same thing. We have these smart defaults. Oops, we have these smart defaults built in. I'll just do a quick build there. Built into both of our front end and our back end. Okay. Now, if I was to start this app now, what's actually happened is the default project has changed to app host. So if I press F5, it launches a single console window. And when that's ready, it launches the Aspire dashboard. I'll zoom in a little bit there. The Aspire dashboard is just awesome. We've got everything we need here. So first, we've got a resources tab, which shows all the resources in our solution. Currently, just the Web API and the Web UI. We'll have a lot more soon. So we can use this feature to stop our application. We can use it to start our application. We can use it to inspect it, so we can see, learn things about our application, such as its URLs, where we can access it. Health checks, there's none showing at the moment. We'll fix that shortly. All of the environment variables that are sitting behind it. We also have this nice little graph, which we'll play with a little bit later. We have console. So instead of juggling multiple console windows, we can now see all console output in this unified view. So I've got my Web API output. You can see there's a little badge there that says Web API, and there's Web UI output. We've got structured logging. So we've got the semantic, more detailed view of what's happening. We have our traces, so we can follow requests as they move through the system. There's nothing in there yet because we haven't used the app. We're just talking about the Aspire dashboard. And we've got metrics to help us use numbers and charts to visualize our app's behavior and its performance. So of course, if we want to access the web UI, we could just click on one of these URLs that we saw before. So if I go ahead and load that up, there's our application again. So let's give it a test. We've got our home page. We can still count things. We've got our weather forecast. I've clicked on that, but nothing seems to be happening. But I did click it. There we go. It was a bit slow there, but it came up. If I refresh this a few times, I'm just hitting Control F5 here. Mostly it's quick, but you can see every now and then it's a little bit slow. And you might be wondering, well, what's happened there? Two things. Our application has become more reliable. It has this retry mechanism. It only retries a certain number of times. So I think we failed 5 retries there. So it'll do its best, but after a certain number of retries, it'll still fail. But let's see if we can learn what happened there. And we can do that using the dashboard. So if we go to, well, that's fun. Let's do a Control F5. There we go. If we go to our traces here, and if I just scroll up a little bit, I might go to this one. Okay, and so you can see that there was a bunch of requests. One of them failed, one of them succeeded. And if we want to, we can click on each of these items to learn more, or we can actually use the built-in GitHub Copilot integration and just explain the trace. And so this is going to start up GitHub Copilot chat, analyze the distributed trace, and give us a whole bunch of information about what went wrong and even some follow-up questions. But I don't have time to read that, so I'm just going to say, explain it to me as if I were only 4 years old. That should bring it back down. Easy explanation. I love this. Imagine you asked your friend for a toy, but the first time you asked, your friend said, oops, I dropped it. That's the error, 500, right? But then you asked again, and this time the friend gave you the toy with a big smile, 200. So at first, something went wrong, but when we tried again, everything worked just fine. No need to worry, you got your toy in the end. So I love that. If we wanted to dive in a bit further, it's going to tell us all about the resiliency that's now built into this application. It'll tell us how it's using poly.net behind the scenes and some retry mechanisms, and it'll tell us that we can go in and customize Poly and its behavior. So I really love that. So you've seen a bit of an overview of adding Aspire. You've seen how we've started to build up our code model of our solution, of our distributed system. You've seen how smart defaults are baked in and where we might start to add our own defaults or change the out-of-the-box behavior. Let's have a look now how we can start to do a little bit more with Aspire. So one thing we can do is add in health checks. We have health checks already that came in with our service defaults, but Aspire doesn't know about them. So if we go ahead and say with HTTP health check and specify the health check endpoint, Aspire will know about Web API's health checks, and we can do the same with Web UI's health checks. So it's at the same endpoint, hosted obviously on Web UI. The next thing we can do is a little bit of orchestration. We can say, Web UI, don't start unless Web API is running and is healthy. And that's really easy. We'll just give this a variable name. And we'll come down here and say, Web UI, go ahead and wait for Web API and also with reference Web API. So there's two things happening there. The wait for is the orchestration that I talked about. Don't start until Web API is healthy and running. With reference is the next thing that I want to move on to, and that's about service discovery. How can we make it easy for Web UI to connect to Web API? Right now, the way that Web UI connects to Web API is we've hard-coded the URL. Now that's fine for this development environment, but it's not going to fly when we move into development in the cloud and staging and production. We'll have to change this in some way. Maybe we can start to move it into app settings. We can manage app settings, or we can use Aspire Service Discovery. And with Aspire Service Discovery, it really gets easy. We're going to say use HTTPS, but fall back to HTTP. And instead of the URL, we're going to specify Web API, the name of the service that we defined in app host. So this is Web API, and here we called it Web API. So now what's going to happen is when this application starts up, Aspire will inject service discovery information into Web UI so that it knows how to find Web API. And I'll show you how that works. So if I press F5, it's really easy to start our application now. We don't have to start Web UI and then start Web API. So you can see that they started one after the other, and that dependency has now been illustrated. Web UI is dependent on Web API. And if we go to Web UI and scroll down a little bit, we can see the URLs are there as before. We've got our references, and we could jump over to Web API straight from here if we wanted to. We've got our health checks. It's healthy. It was last checked 11 seconds ago. We have our environment variables, and this is how service discovery works. It's backed by environment variables. So if we come down here, we've got services, Web API, HTTP. And that's the URL if we want to access it on HTTP. And that's the URL if we want to access it on HTTPS. So they've made it really easy for these services to find each other. And when we deploy to environments in the cloud, we just need to set the correct environment variable. Service discovery will do the rest. So if I load up Web UI, we'll give it a test. Looks like everything's working well. Yes, excellent. All right, let's wrap that up. So that's it. Aspire is now running alongside our app, orchestrating the Web UI and Web API as a single unit. So we don't have to juggle those startup projects anymore. With service defaults, you saw we instantly got service discovery, health checks, resiliency, and telemetry, all without manual setup. The Aspire dashboard provides observability out of the box. So we've got logs, traces, metrics. Issues are now visible and easy to understand, especially once Copilot breaks it down into 4-year-old mode. All right, so now we're going to dive into Aspire integrations. Now, as I mentioned, Aspire ships with ready-made integrations, so you don't have to wire up everything by hand. And these integrations cover the core services every distributed systems needs. So it could be databases and storage, messaging, caching, and observability. Now, an Aspire integration is just a NuGet package. It's a ready-made building block that wires up common services for you. And they include health checks and open telemetry and smart defaults that's baked into the package. They wanted to make it easy for you to get up and running. So as you can see from the examples, Aspire supports a wide range of integrations. Now, right now, our demo app is running on SQLite, but let's improve that. Let's swap it out using an Aspire integration, and I'll let you choose which database we go with. So we have two choices. We have Azure PostgreSQL and Azure SQL. It looks like a couple of people have already voted, but I'll encourage the rest of you to get your votes in now. At this stage, it looks like we're going to be running with Azure PostgreSQL, which is exciting because I've mostly been doing Azure SQL in the previous run-throughs of this talk. So I'll give it a moment longer. But it looks.
I'm gonna bring like the poll and the link in here just in case.
Yeah, do that. We've got a little bit of time, so I'll let you take a chance. Of course, if you wanted to use your phone, you can also scan the QR code on the left. That'll take you straight there.
Bring like full screen.
Now, I've just shown a couple of databases here, but of course, these are just the integrations that I've chosen for this presentation. There are so many more. So if you wanted to choose Cosmos DB or MongoDB or Oracle, I believe there are integrations that support those and a lot more. Of course, every variation of this talk that I include increases the complexity. So in each of the polls tonight, you'll have 2 options to choose from, which, as I mentioned, results in 8 different variations of the talk. All right, it looks like PostgreSQL is going to be the winner. I always say PostgreSQL. It's Postgres. We just say Postgres. It's easier. I forget.
I think we capture all the votes, I guess.
Yeah. All right, let's move on. So let's see how easy it is to wire up Azure Postgres with an Aspire integration. There we go. I said it right for one time tonight. Okay, let's clean up a little bit. And we'll stop this running. So the first thing we need to do is to install PostgreSQL on our local development environment. So I guess that means we jump online, download the setup, or maybe we can use Docker. No, this is meant to be effortless, right? We're going to use Aspire and a hosting integration. So to do that, we just right-click on our app host project and we say add an Aspire package. Now this is just loading up the NuGet package manager. Okay, but it's filtered to show just the Aspire hosting integrations. Now, a hosting integration is a package that configures applications by provisioning resources or pointing to existing instances, such as a local Postgres instance. So if you already had Postgres running and you wanted to point to that, you use the Aspire integration package. If you don't have it running and you want Aspire to spin up an instance for you, you use the Aspire integration package. Easy. So let's find the Postgres one. Okay, so we're going to choose Aspire hosting Azure PostgreSQL. I'll install that. I accept. And then I can jump into app host and we can define our database server. So we've defined our our web backend, our web front end. Now we're going to define our database server here as well. So here we go. We've got a database server. It will be a Postgres flexible server on Azure. We're going to use password authentication. And during local development, we're going to run it in a container. And we've made that container persistent. What that means is the first time that we run our app, it will get the image, it will spin up the container, but it will keep it running. And so when we stop our app and start it again, it will just access the running container. So that means that the first time we run it, it'll be a little bit slow, but every time after that, it'll just use the container that's already running, which is a really nice experience. So we've defined our database server. Why not take it a step further? We'll define our database. So using the database server, we can simply say add database, and we'll call it Effortless DB. And now we need to define our dependencies, right? So our web API will wait for that database. So now web API won't start until the database is ready. And so that we can make it easy for web API to find that database, we'll go ahead and inject that service discovery information also. So with reference to database, inject the service discovery information, which essentially means our connection string to that database will be available in environment variables, and we'll be able to use that. So we've done our orchestration side of things now. We just need to go ahead and update web API to use the new database. So I want to do a little bit of a cleanup first. I like to keep things clean. I'll start by getting rid of the EF Core SQLite package, since we won't be using SQLite anymore. I'm also going to get rid of connection strings. We won't need to store this configuration in app settings because we'll use environment variables and service discovery. I see my chaos middleware. That's the thing that makes the app fail 30% of the time. I'll just go ahead and disable that since we won't need that anymore. There we go. We have our SQLite database. We'll delete that. And then in program.cs, we're grabbing the connection string. We don't need that. And we're wiring up EF Core with our AppDB context and passing in the connection string. Our life's about to get much easier than that. So now, if we want to use Postgres, we can go ahead and install Microsoft Identity Framework Core.npg SQL, or we can use the matching Aspire integration package. To do that, we just go right-click on Web API. Yes, it was Web API. I thought I'd better check. We go Add Aspire Package, and we'll search for Postgres. And you can see here, we've got this one, Aspire, Azure, NPG SQL, Entity Framework Core, PostgreSQL. Now, the reason that we've installed that is because it's an Aspire client integration package. And a client integration package is really smart at wiring up DI and configuration and adding health checks, adding resiliency, and open telemetry where applicable. So we get smart defaults baked in here as well. So if I go to program.cs, remember before we had to get the connection string, wire up the AppDB context, pass in the connection string. Now we've got helper code. We can just say builder.add npg SQL DB context, and it's our AppDB context. And we need to pass in the database or the connection name, and that's Effortless DB. And remember, that name is matching the name that we defined in app host. So it's right here. So we're referring back to that code model of our distributed system. Okay, now there's only one thing left that I need to do, and that's to update the migrations. To save time, I won't do it by hand. I'll just use some that I created earlier. So we'll go ahead and delete those, and we'll grab our PostgreSQL migration. There we go. Now, we'll do a quick build, just in case there are any issues, we'll fix them. It looks good. I'll press F5. Okay, here we go. So Postgres is starting up. Let's have a look at the graph. We need to untangle it a bit. There we go. Oh yes, Postgres started up. Let me zoom out a bit. There we go. Our Effortless DB has been created. Then Web API started. then Web UI started. So we should be able to send bug reports to Postgres now. Submit. No errors. Good. If we have a look at our traces, let's see. Here it is. Yep, we posted the bug report and PostgreSQL, put it into the database. And of course, we can come here and we can see what's happening behind the scenes. There's some entity framework core commands being executed. There's our insert statement. So we still have everything that we have know and love. We just have a little bit more with the Aspire dashboard. And in fact, what I'm going to show you tonight is going to take you all the way through to the cloud. But you don't have to use everything that I show you tonight. Aspire dashboard is an example. That's just one piece. You can use that. You don't have to use everything. So this is about reducing the friction, right? So when you see the things that I demonstrate tonight, think about, for this particular piece, could that address some friction that I'm currently feeling in building a distributed system? If so, use it. And if not, then identify the pieces of friction that you have and try to find solutions to those problems to make them a little bit easier. All right, so I think we're good there. So Aspire integrations, adding a database became effortless. We can choose the database we want. Tonight it was Postgres. We could have gone with SQL Server or anything else, and Aspire handles the rest for us. The hosting integration provisions and orchestrates the database alongside our app, making sure it's ready to start before the Web API starts. The client integration wires up Entity Framework Core with smart defaults and useful extensions. And thanks to service discovery, there's no more connection strings. Well, they are, they're in environment variables, but they're not causing us configuration headaches, right? We don't have to manage that with different app settings files as we move from different environments. All right, let's now dive into messaging. We've seen Aspire in action, but let's have a look at how messaging can improve things. We leverage messaging when services need to communicate reliably, at scale, and without tight coupling. So here's what makes messaging so powerful in distributed systems. Messaging ensures reliable communication between services. So messages don't get lost. They're delivered with durability and with retries. It decouples services so they can evolve and scale independently, and it gives us graceful failure handling. If something goes wrong, messages wait safely and can be retried until the system recovers. Here's an example. We have service A and it sends a request and then moves on. But the message bus stores that request in a queue. When service B is ready, it takes that request, does the work, and sends a reply back the same way. The queues are like inboxes. There's no waiting on live connections. Messages wait safely, and the system can retry if something fails. So that combination keeps our services decoupled and resilient. You know that we have resiliency already built into this app, but it won't help us if the Web API is offline. The resiliency system will retry, 5 times, however you have it configured. If it fails 5 times, that's it. The message is lost. So if Web API or service B in this example is offline, a message bus or a queue can help us there. All right, so in the next demo, we'll start small. We'll add support for messaging. We're going to use End Service Bus, and we're going to use something called the Learning Transport. Now, the Learning Transport lets us see how messaging fits into our app without worrying about infrastructure just yet, but we will get to that. Okay, so a little bit of a cleanup. I'll stop this running. And we're going to work with End Service Bus. Now, if you haven't heard of End Service Bus before, you can think of End Service Bus as the heart that keeps a distributed system running. It works by routing messages to endpoints, and endpoints can send and receive messages. Now, messages are stored until they're delivered, so communication will keep working even if a service goes down. And messages are quite simply plain old C# classes that contain meaningful data. Now, we already have one. In our shared project, we have a create bug request. And so that nService bus recognizes this as a message, we just decorate it with the empty iMessage class. And that just indicates that it's a message that can be sent and received. Sorry, the iMessage interface, not a class. So now that we have a message, we need an endpoint so we can send that message. And we'll create our first endpoint within WebUI. To do that, we'll need to install nService bus. So I'll right-click on WebUI and go to Manage NuGet Packages, and I will search for nservicebus.extensions.hosting. This is going to install nService Bus 10, which was released a couple of weeks ago, along with some integration with Microsoft extensions.hosting so that we can start nService Bus up when the web application starts. So if I go into WebUI, let me just check that I installed that in the right place. WebUI, yes, there it is. So we'll go into WebUI program.cs, and I want to define a messaging endpoint, and I want it to run when the application starts. So I'll do it here. And to define a messaging endpoint, I use an endpoint configuration class. So this is quite simple. We have an endpoint configuration class, and the name is WebUI endpoint. Now it's going to communicate over the learning transport, and its messages will be serialized using JSON. Now, of course, I could have gone with a different serialization. I could have gone with JSON or XML or even a custom format, but I always choose JSON because it's named after me. And we could choose a different transport, and we will do that a little bit later on when we switch this out for something before we go to the cloud. So you can see here we're calling use nService bus, passing in the endpoint configuration, and it will start that endpoint when our application starts. So now we have an endpoint, we have a message, we just need to use that endpoint to send a message. To do that, we'll go into WebUI, Components, Pages, and into my bug report component. Currently, it sends messages using this API client. And the API client is what it's using to communicate with the API backend. You can see it uses it to get the weather forecast, and it uses it to post bugs. We're not going to use that anymore. Instead, we're going to inject an iMessage session. Now that also comes from nService bus, and it's quite simply a service which provides basic messaging operations. Now if I scroll down a little bit, this is my form. And when I submit my form, it will either show a success message or a failure message. We won't have failures anymore. This message is going to be put into a queue, and it'll wait safely until it's processed successfully. So we'll just be showing successes from this point forward. So we can get rid of this. You can see here, previously we'd call the API, check if it was successful or not, and return the appropriate response. Well, we'll just be returning success from now on. So let's grab just that part and delete the rest. There we go. A little bit of a cleanup. So, I got the wrong one. I got most of the right one. There we go. Show success equals true. So all that's left to do is send the message. We'll use our service to do that. Message session.send request. And where are we going to send it to? We're going to send it to the Web API endpoint. Now the Web API endpoint doesn't exist yet, but let's not let that stop us. We'll do a quick build, make sure everything's okay. And let's give it a test run. Our database was already running, so that was a nice quick startup. We'll access our Web UI. We'll go to bug report. and we'll type in a couple of tests. We'll do test 1, submit, success, test 2, submit, and success. Okay, great. So it's working, but where are our requests going? Well, they're sitting in a queue. Now we're using the learning transport, so they're actually just sitting in a folder on the disk in our solution directory. Later on, we'll move to something a little bit more robust, but for now, just so you know, that's where they're sitting. So now we need to create an endpoint that can receive those messages. I'll go ahead and stop this from running, and we'll create that within Web API. So I'll need to install nService Bus there as well. So I'm going to just cheat a little bit. I'll grab the NuGet package here, and we'll pop it straight into Web API. And the next thing that I need to do is go to Web API program.cs and define our Web API endpoint. It's essentially going to be the same as before, the same configuration with a Web API endpoint name, okay? And it's important that this name matches the endpoint that we were routing it to. Now, this is just the simplest approach to routing with nService Bus. There are a lot of different approaches that you can take, but for this simple application, this approach is good. Okay, so we've got our Web API endpoint defined. So now we can receive messages, but what will we do once we receive a message? We need to handle it. So let's create a message handler as well. Now I'm going to create that within Web API, and I'm going to create a feature folder for all the stuff that I do with bugs. So there's my bugs feature folder, and I'll include in that a create bug request handler .cs. So I've got my create bug request handler class, and I'll implement that and make that a little bit bigger. So this is a class which implements I handle messages of type create bug request. It's dependent on our application DB context, and it has a handle method which accepts as input the message that it's received. It uses the message to map that into the bug entity. It then uses Entity Framework Core to add that entity to the bugs table and then save those changes. Very simple. If I press F9 on that, we'll have a breakpoint so we can see it in action. Okay, F5. Oh, let me do a save and a build just in case. Oh, it's looking good. F5. Okay, application starting up. Oh, okay. So we've hit the breakpoint. So that's interesting, right? Because we've hit the breakpoint. Web API is still starting. Web UI is waiting for Web API to start. So let's see what we've got here. We've got our test 1 message came in. It's not lost. And our test 2 message came in. It's not lost. So even though Web API endpoint didn't exist, those messages were stored safely and they were delivered reliably. So now we have 2 levels of resiliency built into our application. We've got poly.net, which will deal with transient failures, retrying up to 5 times. And then we've got messaging, which means our messages will be stored and wait safely until they're delivered successfully. So no messages are lost. Okay, we can improve things still though. One of the things that I like to do is to reduce a little bit of the duplication between our endpoints. So it's important that the configuration between endpoints matches, right? Especially the transport and the serializer. Otherwise, the endpoints aren't going to be able to understand each other. They'll be talking different languages. So rather than duplicating this configuration across each of our endpoints, we can move it into service defaults. So inside of service defaults, I'll need to install that hosting package. I'm going to grab it here from Web UI, and we'll remove the reference from Web UI. We won't need it there anymore. And we'll remove it from Web API as well. And we'll pop it into service defaults. In service defaults, we're going to define an extension method for adding a messaging endpoint. And so I'll do it in the extensions.cs class that was created when we added Aspire. And if I just show you the implementation, let me save the changes there. Got a little bit of a problem here. It's probably, let's see, it's referencing the wrong namespace here. It needs to reference nservicebus.endpoint configuration. I think I just need to remove this one and it'll fix itself up. Yeah, so I just removed the reference to Kestrel. That was included when I pasted it in, just with the way that Visual Studio behaves. So you can see we've got an add messaging endpoint method, which will take a name and then create an endpoint configuration using the name, the learning transport, JSON serialization, and bootstrap it all when the application starts. So with that in place, we can now define our endpoints in Web UI and Web API in a much more simpler way. We can just say builder.addMessagingEndpoint Web UI endpoint. And in Web API, of course, we're going to say builder.addMessagingEndpoint Web API endpoint, just like that. Now, the other thing that I want to do is to include not support for OpenTelemetry, because Aspire supports it out of the box and ServiceBus supports it out of the box. More, I want to let OpenTelemetry know about nServiceBus's traces and metrics. And we can do that in service defaults as well, because that's where we configure OpenTelemetry. So if I go into extensions and we just scroll down, here it is, configure OpenTelemetry. So you can see it's been added. We're adding metrics, we're adding tracing. We just need to include the nServiceBus metrics and tracing. So I'll go add meter, and we will say nServiceBus. That's a pretty good start, but we want all of them. nServiceBus.star. And down here for our traces, we'll add nServiceBus as a source, and we'll copy and paste like a good developer. There we go. And let's do a build. Now, in the past with nServiceBus, up until 2 weeks ago, you had to say endpoint configuration.enable OpenTelemetry, but that's now the default. Okay, so that extension method has been deprecated. OpenTelemetry is enabled by default, which is great. Okay, so let's do another demo before we move on. I want to check out some improved metrics and traces with OpenTelemetry and nServiceBus. Okay, so I'll submit some bug reports. So let's go test 3, test. Let's get rid of our breakpoint. We don't need that. And test 4, test. And test 5, test. That's plenty. Back to our resources, let's go to traces. Okay, what have we got here? There's one. Okay, so we can see that this request has been followed all the way through the system now, from being submitted on our form to being sent using the message session service. Here's all of the nServiceBus properties. To being processed, so received by the Web API endpoint, to being handled by our create bug request handler, and finally to being added to the database to Postgres and the statement that did that. And of course we have metrics as well. So if I go to Web API and we scroll down, we have a look at, say, nServiceBus. I'll just expand that out a little bit. So we've got a lot of interesting metrics. There's processing time, which can be used to find handlers that are running particularly slowly or suspiciously quickly. There's critical time. So that can be used to decide when to scale an endpoint up or down. Scroll down a little bit there. Or maybe I'll just, there we go. I'll make it a little bit smaller. What else we got? We've got, let's see, successes. So we can see how many of our requests are succeeding or failing. We have fetches, handler time. That's an interesting one. So we can see if any of our handlers are taking a long time to run. So we've got a lot built in there now. Starting to look good. I love that graph. Let's add some more resources. Let's start to really fill this up. Okay, so that's it. We've added messaging using an service bus, and it's already running locally with no extra infrastructure. Now, because we're building on Aspire and in service bus, OpenTelemetry was already in place, so adding in service bus metrics and traces was easy. Now we've been using the learning transport locally just to keep things simple. We didn't have to spin up any infrastructure such as a messaging technology or queue, but it's not something that we're actually going to deploy to production. So before we move on, let's decide together which messaging technology we'll use next. So you have two choices today, either Azure Service Bus or RabbitMQ. I'll get your votes in now. This is the quietest I've seen the poll. I hope you're still online and with me. Yay! Looks like we're going with Azure Service Bus, but I'll wait. We had a few more votes than that last time. It's been a while since I've run the RabbitMQ demo. That's something to consider. I didn't pray to the demo gods before this, so could be a failure there. Not sure. And hopefully not, because I'm trying to show the effortless path, right? It's all got to work. All right, looks like we've got 5 votes in. Pretty strong for Azure Service Bus. I'm not sure if I've had that combination before. Usually it goes Azure SQL and Azure Service Bus, or it goes PostgreSQL and RabbitMQ. So that's fun. All right, Azure Service Bus it is. So the next demo will switch from Learning Transport to Azure Service Bus. Now, as you've seen, and Service Bus hides the details of the messaging technology behind a transport. If I can just bring my Solution Explorer back. And we've defined that just within this extension method. So we're using the learning transport. But we can use the learning transport, say, for quick learning and testing. And then thanks to this abstraction, when we want to go into a different environment, we can use technologies such as Azure Service Bus, RabbitMQ, or Amazon SQS, and all we have to do is change the transport. So we can focus on building features instead of messaging technology details. So we chose Azure Service Bus. So the first thing that we want to do, of course, is head over to the portal and use the portal to create a new instance of Azure Service Bus. No, we're not going to do that. This is, again, effortless, okay? So we're going to define our Azure Service Bus resource first in app host. And to do that, we're using an integration. So we'll go add Aspire package, and we want Azure Service Bus. And we have an Aspire hosting integration for Azure Service Bus, which I'll install. I accept. Okay, and now we're going to define our messaging resource, which is Azure Service Bus, and locally we're going to run using the emulator, and I'm configured that, which will basically spin up Azure Service Bus in a container backed by a SQL Server database. And we've said the container lifetime is, again, persistent. So spin it up once and then keep it there for us, because we don't want you to do it from scratch every time. Now, we could also, if we wanted to, actually use a real Azure Service Bus instance. There are some limitations with the emulator, right? It's simple enough for us tonight, but for a lot of scenarios, you're going to want to spin up an instance for your local development purposes. I hope that's not always going to be the case. I hope that we can get a lot of mileage in local development in the emulator. They're making improvements to it all the time. Version 2 was just released, but it's good to keep in mind. So if I was to remove that, Aspire will go into local provisioning mode, and it will essentially prompt you for the information that it needs to create an instance of Azure Service Bus for your local development purposes, which makes it really easy as well. So no, we don't have to go into the portal and do some click ops. So the next thing that I want to do is just define a couple of endpoints. So I want to create a service bus queue, one called Web UI endpoint for our Web UI endpoint, and one called Web API endpoint for our Web API. And then I want to do a little bit of orchestration. So both the Web API and the Web UI will be dependent on this messaging service. So let's copy and paste a bit here. And let's change that. Go away, tooltip. Let's change this to be messaging. And we'll copy and paste that. I'm getting efficiency all over the place. Okay, so Web UI and Web API will now wait for messaging to be available before they start, and we will also inject service discovery information to make it easy for both of those services to find Azure Service Bus. Let's do a build. I always like to do lots of builds. Okay, now we need to switch from the learning transport to the Azure Service Bus transport, and we'll do that within service defaults. And first, we need to install the transport. So we're installing the nservicebus.transport.azure service bus NuGet package. Install. I accept. And then in our extension method, add messaging endpoint, we'll change our transport. So let's go ahead and remove the learning transport. We will grab, using service discovery, our connection string for that messaging endpoint. We're referencing the name of the service or the resource that we defined. If it doesn't work, we're going to throw an exception. And then we just say, whoops, close that. And we're just going to say endpoint configuration.use transport and pass in that connection string. So there's the Azure Service Bus transport. So let's do another rebuild and give it a test run. F5. Okay, we've got a lot more happening now. So we've got, where is it? There's our database. Here's our messaging Azure Service Bus emulator. It is backed by a SQL Server database, which has started. You can see that messaging hasn't started because it's dependent on that database server. Once it starts, then the endpoints are going to be created. And then Web UI, well, Web API will start and followed by Web UI. It's really nice to be able to visualize this system this way. I like playing with that. But they need to lock it in somehow. You know, we can save a view. That'll be a nice feature. All in local development, right? Wow. So cool. All right, it's running. Where's Web UI? Here, everything's healthy. There's our URL. So really, we just want a successful bug report now. What is this? Test 6, test, bang. All right, so now our messages are going through Azure Service Bus emulator. So that's it. We switched from the learning transport to Azure Service Bus transport with minimal effort. Within Service Bus, it was just a small code change made in one place, thanks to the refactoring we did within service defaults. And of course, the transport abstraction, which made this effortless. We can use the same messaging code with any queuing technology. So that's Azure Service Bus, that's RabbitMQ, that's Amazon SQS, that's Azure Storage Queues. The list really does go on. We used Aspire hosting integrations. We added the new messaging resource, and Aspire handled orchestration and service discovery automatically. And really the best part is that now local development couldn't be simpler. One press of F5 launches the entire system ready to test and observe almost instantly. It's pretty much instantly after the first run, right? Once those containers are set up. Can you imagine that experience for a complex distributed system when you have a new developer on the team and you say to them, you know what, press F5. That's it. That's how you get your system up and running. That's really cool. All right, so we've seen everything running locally. Now let's see what it takes to get it into the cloud. So in this section, I'll show you how Aspire and the Azure Developer CLI, or AZD, work together to make your code to cloud journey truly effortless.
That's cool. Hey, Jason,
Yeah.
don't want to
Yes.
interrupt, but like just
No, go
around
for
the
it.
context, we had like a question or a use case from Cosme. Cosme. I'm not gonna be able to pronounce your name correctly, but what he mentions is that he's got like a React front end, a Python back end in Postgres, but he
Yes.
wants to slowly break or this Python monolith, right? So
Mm-hmm.
he bought like different questions, but he'd like to break the Python into multiple .NET services. And he mentioned about Azure Functions, right? Just to make
Yes.
use of those triggers. I think the question here would be like, would that work if he decides not necessary to use a web API, but to use multiple Azure Functions together with Aspire?
Yes, for sure. Yeah, just head on over to aspire.net. You can learn about its support for JavaScript, you can learn about its support for Python, and you can learn about its support for Azure Functions. So they have really detailed documentation and demos there.
Cool.
Good.
No, all good. Thanks, Jason.
All right, no worries. So deployment, Aspire apps are flexible. So the same app can run locally on your machine, in containers, or in the cloud. And when you're ready to deploy, Aspire creates a deployment manifest which describes services and resources, the same services and resources that we've in fact been defining inside of AppHost. We can then use a tool such as the Azure Developer CLI, or AZD for short, to provision those resources and then deploy those services into Azure. And finally, with the same tool, such as AZD, we can then configure a CI/CD pipeline so deployments become automated and repeatable. Now, we're talking a lot about deployment to the cloud, right? And so obviously the tool that I'm using, the Azure Developer CLI, is for deployment to Azure. But I don't want you to think that Aspire only supports deployment to Azure. It supports AWS, it supports GCP, it supports Azure. People are using Aspire to do deployment to on-premises, to IIS. So dig around, there's plenty of resources for you to find. What's cool about what Aspire does is that deployment manifest. It's a JSON file. We'll take a quick peek at it soon, but it essentially describes those services and those resources and how they connect together. And other tools, such as AZD, can use that deployment manifest to do these things, to deploy your app into the cloud, to deploy your app on-premise, to spin up a CI/CD pipeline. So the only question really is, which deployment pipeline should we use tonight? You can choose between Azure pipelines or GitHub Actions. I think the last couple of runs that I've done have been Azure pipelines. So that's pretty tried and true, but you can also choose from GitHub Actions. All right, looks like one vote for GitHub Actions. We got a tie. There we go. Need some more votes. Otherwise, we'll have to pick at random. GitHub Actions. That's okay. I kind of like deploying to GitHub Actions. You know, most of my day job is working with GitHub and GitHub Actions. I don't get to work with Azure pipelines as much anymore. All right, 75% of you voted for GitHub Actions, so let's do it. We'll take our demo app. We'll use Aspire and the Azure Developer CLI. We'll check out the deployment manifest, and we'll set up a CI/CD pipeline using GitHub Actions. And we'll push this into the cloud. Okay, it's cleanup time. You probably saw that coming. We'll stop this running. And the first thing that I want to do is actually, this is going to be deployed to a Azure container app environment. And I want to define that as one of my resources or services within AppHost. And if I choose to, I won't tonight, but if I choose to, I can then configure that environment as part of my app host. So I can use app host to configure the model of my distributed system, not just for local development, but also configuring the infrastructure once it goes into the cloud for those different environments. Obviously, there's only so much I can demo in 1 hour talk. So I won't demo that tonight, but I'll get you started. So all we have to do is define our Azure container app environment, and then we can start doing things like configuring our infrastructure, or where is it? With Azure Log Analytics Workspace, or customizing resource naming. So there's a lot we can do there just by having that. It also means that I won't get a nasty warning in the console, which I don't like, so that'll be good too. The other thing I need to do is I want the HTTP and HTTPS endpoints here to be exposed so they can be accessed externally. So this is for Web UI, so that we can actually use our app once it's deployed. And finally, because we chose Azure Service Bus, what actually happens behind the scenes, where is it, in service defaults, is it uses password authentication to connect to the Azure Service Bus emulator. When we deploy to the cloud, we're going to use managed identity. So I need to have a different approach for our deployed version. So the first thing I want to do is to install a NuGet package called Azure Identity. Install. I accept. And then I'm going to use, where is it, extensions. And then instead of just passing in the connection string, if we're in development, I will create a new Azure Service Bus transport, which is just using the connection string. If we're not in development, then I'll use the connection string, which will actually be a different connection string. It won't contain your username and password. It will just point to the Azure Service Bus namespace, and then I'll pass in the default Azure credential. And all I need to do is just say endpoint, use this transport. Okay, so we've done everything we need to do as far as our app host and service defaults are required. So let's go over here now and have a look at that Aspire manifest. So there's an Aspire CLI that you can install and check out. Tonight we've been using Aspire version 13.1, so my Aspire version matches that. There's a lot of cool commands in there, such as creating a new Aspire project, adding support for Aspire project, running an app host, adding an integration, publishing it. We're going to look at this do command. We're going to execute a specific pipeline. So we're going to run Aspire do publish manifest output path to the artifacts directory, which is where all my build artifacts are currently going, so that we can have a look at that deployment manifest. Give it a moment. It's succeeded. So let's fire it up with code. It's in artifacts, .artifacts. Where are you? What did I output it to? Yeah, okay. Code / artifacts. Code artifacts. There we go. I don't know why that autocomplete wasn't working. Something I was doing. What's it called? Deployment Aspire manifest. There it is. Bring that over here. Zoom in a little bit. So it's just a JSON document. It's referencing a schema as defining our resources. So we've got our Azure Container Apps environment, the Azure Container Registry, the environment itself. We've got our messaging. We've got our 2 endpoints that we created. Let's contract that. We've got our SQL Server. Sorry, my naming convention is not very good. We've got our SQL Server Key Vault. We've got Effortless DB, the database. We've got our web API, on and on and on. So this is describing our application, its services, its resources, how they connect together, other resources that are required because we're hosting it in Azure. Of course, we could have done everything using Azure Container Apps as well to make it a little bit more cloud agnostic, but that takes a little bit longer to set up in a demo. All right, so we've seen the manifest now. Now let's use a tool. We'll use the Azure Developer CLI to use that manifest to deploy that solution into the cloud. Now, if we want to use AZD, we need to make the application or our solution AZD compatible, and we can do that using the AZD init command. So how do we want to initialize this app? We want to scan the current directory. There are other options such as selecting a template or using agent mode, but we'll scan the current directory because AZD is compatible with Aspire and it detects that this is an Aspire application. So I can say confirm and continue initializing my app. It asks me for an environment name. We're going to deploy our first cloud environment, so it's going to be our Effortless dev environment. And it's done. Our application is now AZD compatible. It's generated an AZD configuration file called azure.yaml and a markdown document called next steps. If we go in there, we can learn all about AZD and all of the cool things that we can do with our application now that it's Azure Developer CLI compatible. It gives us some examples here. If we want to, we can run AZD up right now and deploy to the cloud. If we want to not use the Aspire deployment manifest, if we want to manage our own infrastructure as code, we can run AZD infragen and generate some bicep and take full control of those side of things. But we're not going to do either of those things. We want to set up a CI/CD pipeline to do everything for us automatically so that we just need to commit our code. To do that, we use AZD pipeline config. Now we chose GitHub Actions tonight, right? So we'll go with GitHub and we're going to give it a principal name. Now the principal name is the service principal that will be created in Azure for us by this command, by the AZD pipeline config command. And this service principal will allow GitHub Actions to connect securely to Azure to provision our resources, such as our SQL Server, Azure Service Bus, and Key Vault, and deploy our services, such as the Web API and the Web UI. So if I run that now, it's going to start a really cool workflow that's going to do absolutely everything for us. It says, which subscription would you like to use? I'll use this one, Visual Studio Enterprise. It says, where do you want to host it? I'm in the east of Australia, so I'll host it there. It says, you know what? You don't have a CI/CD pipeline. Would you like to create one? Would you like us to create one for you? It's a basic workflow to help you get started. Yes, please. I can just press enter. It's the default choice. It says, you know what? You're some kind of cowboy. You're not even using source control. Do you want us to initialize a Git repository here? Yes, please. Just press enter. It says, okay, so you want to use GitHub Actions. You're going to need a GitHub repo. Would you like us to create that too? Yes. I'll just press enter. What's the name? I'll just press enter. Effortless. Let's see. Effortless is already in use. Of course it is because of my demo earlier today. So we'll call this Effortless Dev. All right. Okay, so now we're going to choose the credentials. So we're going to use a federated service principal. So we'll have our service principal with OpenID Connect. So we use federated credentials to connect securely between GitHub Actions and Azure. So it's creating that for us. I don't know about you, but I really hated having to create this manually or even write infrastructure as code to do this. It was annoying. I love that this is doing it for me automatically. Give it a second. So it's done that, and now it's also created the GitHub repo, which we can go and take a look at. It's also configured GitHub Actions with all the variables it needs to run that CI/CD pipeline that it created for us. And so it has one last question. It says, would you like to commit and push your local changes to start the configured CI/CD pipeline? And all I have to do is press enter, and it'll do that for me. And it'll probably prompt me for a password. Oh, okay, no password needed today. I must have committed recently. All right, so we can just go GitHub browse. So we've got the GitHub CLI installed. That actually comes with AZD. So we go GitHub browse. That'll take us to our new repo, which has just been created. You can see all of our codes being checked in. Here's that next steps document I was telling you about, so you can learn all about AZD. So you can see the things that we did. You can also come over to actions, and we can see the pipeline that's now running. So if we jump in here, you can see that it's installed Azure Developer CLI. It's going to use Azure Developer CLI in this pipeline. It'll use two AZD commands. It'll use provision, AZD provision, to provision the infrastructure in Azure. And then it will use AZD deploy to deploy the services to Azure, so Web API and Web UI. So you can see it's already jumped into, it's authenticated using the federated credentials, and it's now jumped into provisioning that infrastructure. So if we go over to Azure, soon we'll see that resource group apply. Here's the one I did earlier, but pretty soon our effortless dev will appear. But that does take a little bit of time. That's the one I did earlier. It can take 10 to 15 minutes, depending on how the cloud is running on any given day. So we won't wait around for it to finish. Yeah, I'm refreshing a lot. All right, we won't wait around for it to finish, but you can see it's underway, and it's going to deploy the infrastructure and deploy our application. And so here we go. And if we go to the one that I created earlier, we can have a peek at all of the resources that it will create. So this is a little bit harder to see, so I'll just zoom in. There we go. So we've got some managed identities. We've got our container apps environment. We've got our container registry. We've got log analytics workspace. We didn't define that, but it's a smart default, right? So we've got log analytics workspace already there. We've got a SQL database. We've got our Azure Service Bus namespace, SQL Server, managed identity for SQL Server, our Web API. Sorry, this is the Web API container app, and page 2 is our Web UI. Now, if we come over here to our Azure Container Apps environment, we can see one of my favorite features, and that's the Aspire dashboard. So in this deployed Azure Container Apps environment, we have the Aspire dashboard available and running, ready for us to use in the cloud. So this is locked down, right? Because I'm authenticated into the Azure portal, I can access this dashboard, so it's not public. I can also configure some settings for this dashboard. This is really cool. Logs destination. The logs are going to Azure Logs Analytics, right? So they're being stored. Now I can also use application insights, and I might use that for a more detailed, in-depth analysis of my system as it runs over the coming months and years. But for a quick look, I'm definitely going to use the Aspire dashboard. That's the tool I'm using in development. I know it and I love it. I want to use it in the cloud if I can. And you can see I changed the destination. Before, the dashboard just used to store it in a stream, so you couldn't kind of use it long term, but now you can. Another feature I really like with the Aspire dashboard is you can actually go and just clear everything. So that means that in local development, you can have a fresh start. You can try that problem you're having with a fresh set of logs and telemetry and really drill down on it. It also has keyboard shortcuts, so you can navigate it really quickly. So you can see there's Alt-R, Alt-C, Alt-S, Alt-T, and M. I think they're Alt. I don't. There we go. No, it's just C. There we go. C, S, T, and M. So you can dive around really quickly. Question mark to bring up help. Pretty cool. All right. I wouldn't mind having a peek and seeing how this is going. Yeah, all of our infrastructure has been provisioned. That's nice. What else we got? We can see our application running. So if I go into Web UI, hello world, we can still count things. We can still get the weather forecast. So it's nice and quick. We can submit the bug reports. Not as many of those now. It's a little bit more reliable. What else? Oh, let me show you the pipeline that we're running. So this is the pipeline that we got for free, right? We didn't have to create it, but we can. Oh, not that one. That's the Azure DevOps. That's the one that I created earlier. Where is it? Azure dev.yaml. This is ours now. This is our pipeline as code. Where is it? There it is. That's the link I was looking for. So you can see that it runs. We can run it manually, or it'll run when we push code to the main branch. It specifies the permissions that it needs. It passes in all of the variables which have been configured in this repo. It passes, and then it's got a number of steps. So it checks out the code, installs AZD, installs .NET. You can see it's covering all the bases there. We're running on .NET 10 tonight, so really we just needed 10. So we can go in and change this and deploy a new version. Log in with Azure, provision infrastructure, deploy application. You know, it's missing some tests, right? We want to do some CI/CD tests. We want to do some tests before we actually deploy. We can also use the AZD package command when we're ready to extend this workflow. So we can package the services, store them in artifacts, and then deploy that same set of packages across multiple environments. Maybe we have a check before we go to staging or production. So we can do things like, what is the command? It's been a while since I looked at it. AZD infra, no, it's not infra. It's AZD provision. That'll provision our resources, but we can run AZD provision preview. So we can run that command in our CI/CD pipeline to get an idea of what infrastructure is going to change if we do approve this deployment. So we've got a really cool set of tools here, right? Aspire, End Service Bus, Azure Developer CLI. We're not taking any shortcuts. We can have infrastructure as code if we want. In fact, it's simple. We just go say AZD infra gen. That's going to read that Aspire deployment manifest, generate the infrastructure as code, and we can jump in and check it out. Like it's here. So we're not taking shortcuts. We're doing things the right way. We're just doing them the effortless way, a little bit more efficient, a little bit less friction, because we've found the tools that work for this scenario and make our life a lot easier. And that's what this is all about. All right. With Aspire, our C# app model became the source of truth. We didn't write any Bicep, ARM, or Terraform, although we could have. The deployment manifest describes our entire system, and that fed directly into AZD, which then handled packaging, provisioning, and deployment within a CI/CD pipeline. We used AZD pipeline config. It created a repo. It generated and configured a CI/CD pipeline. It set up secure credentials, and it all happened automatically. There weren't any manual steps required. And because the pipeline's defined in code, extending it now for staging or production is straightforward. And I can help with that. You can reach out to me if you have some questions. All right, so that's all from me tonight. If you'd like to explore these ideas further, then go ahead and scan this QR code. It'll give you 90 days free access to the Distributed Systems Design Fundamentals course by Particular. That's the company that I work for. It's a great course. It's packed with 11 hours of practical, hands-on content, which will really help you level up your distributed systems journey. I should paste that into chat.
Oh, yeah, if you have the link, I can just share.
Yeah,
nice.
I will do that. I will do that as we do our Q&A. All right, I hope you've enjoyed my talk tonight. The key takeaway is simple. Choose the right tools, remove friction, and focus on what matters, delivering features that make an impact. Thank you.
Amazing. Thanks, Jason. That's I really enjoy the journey, right? Starting simple and going onto like those different paths and making like those decisions and being flexible and effortless, creating, connecting
Yes,
things, even get to Azure in the end. Wow,
that's it. Yeah,
that's pretty cool. Yeah.
I'm sure. I'm
Uh,
sure it will finish too. Like if we keep an eye on it, I'm sure we'll have a success. It feels like a no demo failure night tonight. Yeah, we're past our provision. We're on to deploy. I did forget to mention too. I have a few copies of this book, Dr. Harvey and the 8 Fallacies of Distributed Computing. We talked about one briefly tonight. The network is reliable. It's not. Surprise. So I want to give away a few copies of this book. So maybe we'll focus on best question. If you don't want to ask a question tonight, though, you can also reach out to me at connect.jasontaylor.dev. LinkedIn is probably the best approach. You'll find my LinkedIn account there. But this book's fantastic. It's a book that captures many of the realities of building distributed systems. So if you do want one, ask an awesome question or feel free to reach out to me on connect.jasontaylor.dev.
well, let's give it like a few minutes. Right? People are just mentioning about like the talk, like was great. I'd like also like together, like as Jason is offering like copies of his book for the ones that are asking questions. Or I also like would like to share like a link with you guys, just if you want to get JetBrains license, right? I got two. So just feel free to post a message onto this URL, which is the meetup, right? So just say, please, hi Marcel, I'd like a license, and then you're gonna get a license, a JetBrains license. I have two available, so just feel free to put like a message over there, and then I'll reach out, and yeah, send like the license to your email. Let's see,
Very
like
cool.
let's see if more questions come, right? I think like there was only one scenario that one of the Cosme Vladuto, he asked about breaking down the Python.
Oh,
Makes sense,
yes.
right? For bringing
Yes.
working multiple services, having Aspire to manage like the developer experience, right? In general, like that's what I
Mhm.
do. The developer experience, I use Aspire everywhere. But like when it gets to deployment, it depends, right? So
Yeah.
I think that's a decision of the team that's working on a specific product or on the engagements with the clients. My question for you, Jason, how do you do it? Like, so uh, on particular, so do you guys leverage Aspire all the way, even like with deployments?
Mhm. So we're lucky. We're in a position that we can explore tools such as Aspire, but we're actually in a different position because we're not consultancy. We're not looking at how our clients are building systems. We're looking at how our users of N-Service Bus and the particular platform are leveraging tools such as Aspire. So really, we're waiting for you to reach out to us and tell us how you would like to use Aspire when you're building distributed systems, so that we can respond to that and implement those practices within our platform. And in fact, there's a way you can do that. If I bring up if you go docs.particular.net, and if you go, this is a really great resource. It covers everything to do with N-Service Bus, so feel free to check it out. But if you come here to Shape the Future, you can see another sample with .NET Aspire, or Aspire now. I'll update that. I need to leave myself a note so that we can change that to Aspire. So this is a sample. I think it's using RabbitMQ and PostgreSQL, and it spires up the whole particular platform. So you get some tools such as here, you can learn all about the service platform here, which basically includes service control and service pulse, so that you can monitor your live distributed system and retry messages if they fail and get an idea of really what's happening with your system. Here's a question.
We got a question from Cosme. So he mentioned like, when do you think that Aspire is a little bit too much?
When talking about a production product,
products.
Okay, so let's think about that. That's a really good question. I really like that. When we go into production, what parts of Aspire might be too much? Maybe we don't want the Aspire dashboard in production. Maybe we have our own tools such as Application Insights or Raygun or Service Pulse, and we don't need a tool such as that. Well, that's an option. We can turn it on or off. Okay. What about service defaults? Well, that came from Aspire, but I could get rid of most of the things associated with Aspire, maybe not service discovery, and still use those service defaults, right? We had resiliency with Poly.NET, we had open telemetry. These are all just pieces of a really large puzzle, and I can pick and choose which ones I'd like to use. So when you ask the question, when can Aspire become too much? It's when one piece of that puzzle causes you friction, you stop using it. And you use the approach that is effortless, the approach that doesn't cause you so much pain. That's it. That's all it is. You've got to find those tools and those packages and those techniques that make it easy for you to build distributed systems, or any system really. We talked a lot about distributed systems tonight, but you can use Aspire with a simple app as well. Great question. If you would like a copy of the book, just reach out to me on LinkedIn, and I'll post one out to you.
Congrats, Cosmin. Yeah, that's exciting. There's another question. People are excited now. So let's bring in here. Going from doing and that. So try any agents, AI agents for editing and developing Aspire applications. Any recommendations on which ones to understand Aspire? I'm thinking, how can I get an AI agent to do what Jason Taylor can do?
Oh, that's a good question.
Yeah.
You know, what I love about what we did tonight is that we created a lot of code and information right inside of our solution that an AI agent can leverage. So, hey, deployed. So, if you think about what's in our solution here, we have infrastructure as code. An AI agent can leverage that to understand more context about our solution. The AI agent can go into github.azure dev and understand how we're going to build, potentially test, and deploy our solution. So now we have CI/CD pipelines, and we have infrastructure as code. We also have in our artifacts, we have our deployment manifest somewhere here, Aspire manifest, there it is. And we have our markdown documents. So really, the next step would be, not this next step, but maybe to create an agent.markdown file to give whatever agent we choose really great context about our solution, maybe referencing some of the things that I've just pointed out. And so at that point, you can work more efficiently with your agent and with the Aspire application that you've built. Now, if you're looking to do something from scratch, that's not typically how I operate. I tend to build templates first. And so I'd be looking at using a template for the solutions that I typically build, and then starting there. So my template's going to include all of these things. It's going to include the infrastructure as code. It's going to include Aspire compatibility, AZD compatibility, to get me up and running, right? Just a simple start that I can build on and extend. So then the agent that I choose in that scenario too, even from a file new project scenario, is going to have access to all of that context, and is therefore it's going to be easier to build on that context. As for which agent I would choose, at the moment I'm using Claude. So that's my preferred. I do use GitHub Copilot, I do use Claude, and I do use ChatGPT, all for different things. I think I may settle on one day, but I don't think it's going to be any time soon. There's just too much change and movement in that space. Great question. Again, yeah, reach out to me if you'd like a copy of the book. I'd be happy to post one out to you. All right, I think we have
Awesome.
time for one more question if there's anyone else.
Yeah, another person comes up. So far, we have like two questions. So doing, just thinking for the
Welcome.
session. I'm gonna reach
Welcome.
out to you, Jason.
That sounds good.
But
And Marcel,
yeah,
thanks so much for having me. It's been a long time coming. I know we talked on LinkedIn years ago, and I didn't forget. I was like, I'm gonna present on Coding Nights one time. So I'm glad we could do it.
yeah, thank you. Thank you for for becoming available and sharing the session. I think like that was really insightful. And I know that in general you have like your session, you share with other user groups. This one is very special because it comes from you. It's been a
Yeah,
while, like since like I reached out, and now you had the opportunity to come and share. And within the context of Aspire, right? So we're all using, but it's
yeah,
nice that now AI is coming and
yes.
making things like more like creative.
Maybe
And
that will
yeah,
have to be the next talk. We take what we did
yeah,
tonight and build on it further. That could be
correct.
fun. That could be fun.
That'd be nice. Well, please reach out like when you have the session available. I'm keen to, to have like more sessions from you. And yeah, if you're keen to come and share again, yeah, yeah, gonna be
Wonderful.
very gonna be very welcome. Yeah. So
Wonderful.
we don't
Thanks so
have other
much, Marcel.
questions. In but yeah, I'd like to, as I said, thank you the audience for staying with us like a little bit longer, but like it was worth just checking like Jason's session. And Jason, any other final comments? Where you're gonna be next? Or yeah,
Actually, yeah, I will be at NDC Sydney in April. So if you're heading to NDC, it's definitely worth checking out. You can learn more at ndcsydney.com. And yeah, I'm gonna run this talk again, and I'm going to give a workshop on practical clean architecture and DDD with .NET. I'd love to see
awesome.
you there.
Well, yeah, you guys know Jason. Just follow him on LinkedIn, and yeah, just be inspired by like his career and like what he's been doing with the community, right? So yeah. Well,
Thanks, Marcel.
so now we're getting like to the ends. Thanks again. We're going just to finalize and be connected to us on the user group. We're going to have more sessions now in March. We have like two sessions booked up. I just need to announce to the user group, but it's pretty cool that people are coming to share. So yeah, and I invite you to come and share as well. If you're just attending the audience, right? We're open here to discuss technology. We love it. We love that. So well, have a great evening and talk to you guys soon the next time.
Bye, everyone.
Yes.